Okay, class. So today we are going to be adding, subtracting, and multiplying polynomials. Remember, if I'm moving too fast for you, just let me know. Use the raise your hand tool or unmute yourself and say, Miss Reyes, could you please slow down? This is page 9. And the first thing that we're going to do is adding and subtracting polynomials. We watched a video on this. I had a video, you to watch a video. What was that, Monday? Monday or Tuesday? Monday. Yeah. Today's date is 4/22/2021. When you are adding or subtracting polynomials, what you're really doing is combining like terms. Super duper important. So as we do with everything that's super duper important, we put a star beside it. When you add or subtract polynomials, you are combining like terms. You are combining like terms. Okay, Ms. Reyes, what's combining like terms? What does the like terms mean? Like terms are must have the same variable and exponent attached to it. So semicolon, and we're going to say like terms must have the same variables. Put same. And exponents attached. Oops. To that variable. Or to those, because it has to be, all of them have to be the same. And that will make more sense to you as we go along. So not only do like terms have to have the same variables attached, but they also have to have the same exponent attached to those variables in order for them to be like terms. Okay. So let's do some examples. Let's do some examples. All right, for adding, we're going to do 6 examples, okay? Number 1, we have the binomial or polynomial, poly meaning many terms, more than one term, plus another polynomial or binomial. Binomial because it's 2 terms, polynomial because it's more than one term. Okay, so you can either say binomial or polynomial. So we're going to combine the terms that are alike. Okay. We always line the terms up by which term has the highest exponent goes first. So the term that has the highest exponent, we're going to write it first. Here it's p to the second. Okay. And we got another p to the second over here. And we don't have another number that has a term to it. But so we're just going to go ahead and leave that out. All right. So we got minus 3. We're going to add. Underneath, we have this right here, 2p to the second. We're going to line it up with this term because they're exactly alike. They have the same variable and exponent attached. They're like terms. And then we have this negative or minus 3p to the third. And there's not a term here that's like it, but it would go first because its exponent is higher. So we're going to put it up here. It's negative 3p to the third. And this is a positive, so we're just going to put a plus here. As placeholders, we're just going to add zeros. So we're going to put a 0 here as this placeholder to hold this place. And we're going to put a 0 here to hold this place. We're just going to add zeros as placeholders. And it'll make more sense to you as we do more practicing. Okay? All right, so now when we add, we have 0 plus this negative 3p to the third, and that's just going to be negative 3p to the third. Next, we're going to add these terms together because they're alike. So this is 5p to the second plus 2p to the second. So that's going to be 7p to the second. Okay. Last, we're going to add these terms together. This gives me a negative 3 plus 0. Negative 3 plus 0 is just negative 3. And this is going to be your answer. Brandon, please go ahead and write this down, babe. I'm going to pause for the calls. All right, we have a to the third power minus 2a to the second. Then we're going to subtract. We have 3a to the second minus 4a to the third. Please copy that down. All right. So we're going to order it by highest exponent. The highest exponent of these is the a to the third. So we write it first. We got to the third minus 2a to the second. We're going to subtract. So we put subtraction out here. This binomial, we have 3a to the second. We're going to put it under the term that it's like, and it's like this term. So we're going to put it here. This is positive 3a to the second. So positive. Then we have this minus or negative 4a to the third. So we're going to put it under this term because these terms are alike. Any questions about how I line those up? Okay, so now let's subtract. There's automatically a 1 in front of this variable. So what you have is 1, and it's easier sometimes to see it side by side. So we have 1 minus a negative 4. What does this equal? What's 1 minus a negative 4? And 5. Okay. So this is going to be 5a to the third power. And let's do this one. We have negative 2 minus, is what we're doing, 3. What does this give us? What's negative 2 minus positive 3? What does that give me? I can't hear you, baby. Mm-mm. This is going to be negative 5. This is plus a negative, so this is negative 5. So negative 5, and don't forget, if you forget your rules for integers, please use your calculator, okay? Negative 5a to the second. This is going to be your answer here. Any questions? Number 3. You have 4 plus 2n to the third. You're going to add, we have 5n to the third plus 2. So these are 2 binomials that we're adding, or 2 polynomials that we're adding. Here, the one with the highest exponent, we're going to write first. So that's 2n to the third. You see how the exponents are the same? We don't have any that are in the middle. So I'm just going to go ahead and write plus 4. We're adding So we're going to put 5 into the third under which one of these terms? The first one or the second one? The first one. Then we're going to put 2 under the 4 because they're like terms. So now let's add this together. We got 2 plus 5. What does that give me? 7. So this is going to be 7n to the third. Now we're going to add 4 plus 2. What's 4 plus 2? 6. Okay? This is your answer here. Any questions about that? Okay, let's do number 4. We got 4n minus 3n to the third. We're subtracting 3n to the third plus 4n. We're going to do the highest exponent first. We're going to write that one first. So this is going to be negative, take the sign with it, negative 3n to the third power plus 4n. We're subtracting. We're going to write this under its like term. This is a positive 3n to the third, so we're going to put that under here. Positive 3n to the third. Then we have positive 4n, so we're going to put positive or plus 4n, and we are subtracting. Sometimes when you're dealing with integers, it's good to see it side by side. This is a negative 3 minus positive 3. Okay? What does this give us here? Negative 6. Good job. So this is going to be negative 6n to the third power. This is 4 minus 4, which is what? 0. So this is your answer because this is 0. Any questions? Okay. 5. We have negative 4k to the fourth minus 14 plus 3k to the second. Then we're going to add negative 3k to the fourth minus 14k to the second minus 8. So we got 2 trinomials that we're going to add together. All right, here we go. So this one has the highest exponent. I always wondered if they still did that or not. But this is the highest exponent, so it goes first. The second highest is this one. And then the third is this one. Okay? So this is a plus. Okay? So now we're going to put this term under its like term, which is this one right here. Then we put this term under its like term, which is this one. And then we put this one under its like term, which is this one, okay? So now we're going to add them. So now when we add them, it's sometimes easier to look at it side by side. This negative 4 plus negative 3. What does that give you? Yep, negative 7. Good. So negative 7 k to the 4th. And then easy to write side by side. So this is 3. This is plus again. This is negative 14. What does that give you? Negative what? 11. Negative 11. Good. Yeah, that's negative 11. And then here you got negative 14 plus a -8. What's that give you? -22. Yep. Okay. All right. And so this is your answer here. Pause for the cause. Give you a chance to write that. Number 6, last one. All right. So let's look at this one. You have number 6, 8n minus 3n to the 4. Then you have plus 10n to the second. You're going to subtract 3n squared plus 11n to the 4 minus 7. Okay. See if you could do this one on your own. See if you could do that on your own. I mean, this, then this, line it up. Now you're going to subtract. It's easier if you see it side by side. So that's what I'm going to do. 3 or -3 minus 11. What did that give you? Not 8. Type it in, little jokers. What's -3 minus 11? Okay, good job. Minus 14. Good job. So we got minus 14 or -14 into the 4th. Now we got this one. Look. 10. This is 10. Minus, that's what we're doing is subtracting, 3. What did that give you? 7. Very good. So this is 7n squared. Then we got 8 minus 0. And that's easy. That gives you just 8. Okay. And then this one is 0 minus a -7. What does that give you? What is minus a negative? No. 7. Positive 7. And this is your answer. That's why it's important to line it up like this. Because this you probably would have missed very easily. Okay? So that's why that's super important. Don't just combine like terms without thinking about the minus part, especially when you're subtracting. All right, in the chat, I need you to write easy, medium, or hard with adding and subtracting polynomials, okay? So all you're doing is in the chat, you're going to type easy, medium, or hard. I think this is a lot easier. Multiplying is a lot easier. So we got Q4, page 10, and we are multiplying polynomials. I think this one's going to be easier for you. Pause for the cause to give you a chance to write. All right, so here we go. We are going to use distributive property to multiply polynomials. Now, there are so many ways to do this, and you'll learn other ways in math too. But due to lack of time, we're only going to just do one method this year, which is going to be just distributive property. You'll probably do box method. If we have time, we'll go through some other methods, but if we don't, we're just going to stick to distributive property, okay? So we're going to use distributive property to multiply polynomials. And again, there are so many different ways that you can multiply polynomials, okay? We're going to go and do some examples. First example, example number 1. We have 6v parentheses 2v plus 3. Okay. All right, so here we're multiplying this monomial times this binomial. So we're going to do distributive property one time. We're going to distribute this 1 6v times both numbers in the parentheses. So here what we have is 6 times 2, which is 12, And then we got v times v. Some people find it very hard to do the multiplying. V times v is just v to the second power, okay? You add the exponents. 1 plus 1 is 2, okay? If it was v to the second times v to the third, then you add the exponents. 2 plus 3 is 5. So this will be v to the fifth, okay? Questions about this? This is laws of exponents. If you forgot this, go back and look at your notes on laws of exponents. Any questions? Okay. So this gives you v second. Now we have 6v times a positive 3. And this gives me a positive 18v. And this is my answer. Any questions about that? Let's do number 2. If I'm going too fast, just let me know, okay? You have the number 7 times the binomial negative 5v minus 8, okay? You're going to multiply 7 times both numbers or terms in the parentheses. What does this give me? What's 7 times a negative 5v? What's 7 times a negative 5v? Anybody? Negative 35, what? V. Very good. What's 7 times a negative 8? Minus 56. This is your answer here. Okay? Any questions about number 2? Let's look at number 3. 2x parentheses negative 2x minus 3. We're going to do the same thing again. Distributive property. Okay. We're going to multiply 2x times a negative 2x. What's 2x times a negative 2x? Negative 4 x to the second power. Very good. X times x is x to the second power. Now we're going to do 2x times a negative 3. What does that give us? Negative, somebody said it, I think. 6x. Yep. And this is your answer here. Okay. Number 4. Real quickly, see if you can do this one on your own. 4 parentheses v plus 1. See if you can do that one on your own. All right, Jay, what you get?
Negative 4v.
Negative 4v minus 4. Very good. Okay, excellent job. All right. Let's do one that's like this one. Number 5. We have binomial or 2 terms times another binomial. And again, a lot of times next year, your teacher will probably want you to use what you call the full method, which will be a little bit different from what we're doing now. But it's all the same. You're going to get the same answer if you do the math right, okay? So let's go ahead and use the distributive property for this problem. Since you have 2 numbers up front, a binomial instead of this monomial, you're going to do distributive property twice. If it was 3 terms up here, you do distributive property 3 times. 1 number up here, a term, you do it 1 time. So now that you have 2 terms, you're going to do distributive property twice. So you're going to distribute the 2n first. 2n times all of this is in the parentheses, 6n plus 1. Then you're going to do the positive 2, so plus 2, and you're going to distribute it times the numbers that are in the parentheses. So you're going to do distributive property twice, okay? So let's do this, and then afterwards, you combine terms that are alike. So you're going to multiply the 2n times both the numbers in the parentheses here, positive 2 times both of the numbers in the parentheses there. What's 2n times 6n? 12n to the second power. Very good. What's 2n times 1? 2n. Okay. Now let's do this one. It's a positive 2. What's positive 2 times 6n? That's 12n. It's positive 12n. What's 2 times 1? 2. So now all we do is combine terms that are alike here, right? Is there a term, another term that's like this n to the second power? No. So we do it first, just bring it down. Is there a term that's like this one? Yes. What other term is going to be like that one? The positive 12n. When you combine these terms together, what do you get? 14n. So this is positive 14n. Okay. And then last, you have this plus 2. This is going to be your answer. Okay. Let's do another one just like it. Number 6. Any questions, comments, or concerns before we move to number 6? All right. So we have 4n plus 1. Then we have 2n plus 6. Okay. All right. So again, we're going to do distributive property twice because in this first parentheses, it's 2 terms instead of the 1 that we did up here. Okay. So we got 4n. We're going to distribute it first. Then we got positive 1. We're going to distribute it second. And then afterwards, combine the like terms. So let's distribute the 4n first. Okay. What's 4n times 2n? 8n to the second power. Good job. What's 4n times a positive 6? Positive 24n. Good job. What is 1 times 2n? 2n. What is 1 times 6? 6. So now we're going to combine like terms. Is there a term that we can combine with 8n to the second? No. Write it first. It's the highest exponent, so write it first. Is there a term that we can combine with 24n? Yes. What is it? 2n. When you combine these together, what do you get? 26n. So this is positive 26n. And then last we have what? Plus 6. And this is your answer. Any questions about that? Okay, let's see if you can do this one on your own, okay? Try this one. Anyone still copying this before I move to another page? All right. You have 2 numbers here, 2 terms, 4n plus 2. So you know that's distributive property twice, right? You have 6, a to the second, minus a plus 2. You're going to do distributive property 2 times. See if you can do that. I'll pause the video. All right, so we're going to do distributive property twice. So this is the first number. We have 4a. I'm going to distribute it to what's in the parentheses right beside it. That's 6a to the second minus a plus 2. The second number, that's plus 2. We're going to distribute it as well to the number in the second parentheses, or numbers in the second parentheses. All right, so we have 4a times all of these numbers here, 2 times these numbers here. So this gives me, what's 4a times 6a squared? 4 times 6 is what? You said 24? Okay. And that's going to be a to what power?
Two.
Very good. This is 1, this is 2. This is 1, this is 3. So that's, 2, so that's going to be 3. Now, what is 4a times negative 1a? Come on. Negative 1 times a positive 4 is negative 4. A times a is a to the second power. Okay. Now we got 4a times 2. That's going to give me a plus 8 a. Here, when I distribute, this is going to give me 12a squared. When I distribute this is going to give me 2a. And when I distribute here, that's going to give me 4. So my final answer is going to be 24a to the third. Then I'm going to combine these two together. So this is going to be plus 8a to the second. Then I'm going to combine these two together. And that's going to give me 6a. And I'm going to bring down the 4. This is my answer. All right. In the chat, I need you to type easy, medium, or hard. If you need to watch the video, please go back and watch the video. I'm going to post it on my on the page and send it in the remind. Okay?